Hello children, welcome all for today's science lesson. I hope that you are keeping well at home, enjoying your vacation. Let's see what's lesson today. Changes in matter. So that is the 16th lesson in your textbook. So under this lesson you are going to study about the competency level 2. Under that competency level, so you are going to complete that investigate matter, properties of matter and their interactions to enhance the quality of life. Under that competency, you are going to complete the competency level 2.4. That is, uses chemical changes suitable to fulfill necessities in life. Okay, then if we consider about that lesson, so there are some learning outcomes. So let's see what are those learning outcomes. At the end of lesson, you will be able to differentiate chemical changes and also the physical changes. Then conduct simple activities to demonstrate chemical reactions. And third, the write balanced chemical equation using inspection method. And finally, you appreciate the importance of chemical symbols, formula and equation as a way of communication. So I think you are going to study about these different things and get something related to that one. So let's move to the lesson. First, matter. I think all of you know about matter. All the things present in the environment, they are made up with matter. And what is matter? So you are confusing about that one. Matter, so the scientific answer of matter is anything that has mass and occupies space. Then let's see how we get the idea about matter. Mass. So you know, mass is how heavy something is. Think about an occasion that you are going to consult a doctor. At that time, the first thing they ask you to do is stand on the scale and they are going to measure your weight. At that time, the scale, it gives the reading for you about your mass. As the same way, if you are getting all the matters which are present in the environment and keep on a scale, so at that time it gives a reading relevant to the mass of it. Now I think you are familiar with that one. That means all the matters which are present in the environment, they have a mass. Then, okay, look at this picture. In this picture, there are several glasses and we are going to fill that glasses with the water. So it is given in here. The first one starting and the last one, it is fully filled with the water. That means the water takes the space inside of the glass, and also by looking at this picture you can observe how that space inside of the glass is getting by the water that we are pouring into it. Okay, I think you get that idea. That means if we consider about all the matters, they have a mass and also all matters, they are occupying the space. Okay, then if we get the matters which are present in the environment, they are not comes in the same way. That means they are not comes in same forms or same states. So let's see what is the reason for that one. That means the matters, they can become in different states. One state of matter is solid. Look at this example, rocks. So if we consider about the rocks, they have a mass and also they take the space from the surrounding. That's why we can take rock as a solid matter. Let's see another example for solid matters. Another example for the solid matter is ice cubes. Then if we get the ice cubes, they also have a mass and also occupy space. That's why we can get ice cubes as the solid matter. Then we will move to another example. Think about the balls that we are using for playing. So if we get the balls, they also solid matter. They also have mass and occupy space. Let's see another example. You know, animals. There are a lot of animals we can find in our surrounding. If we get all these animals, they are also solid matter. Here there are some few examples of animals who belongs to the solid matter. Giraffe, panda, elephant. Likewise, all the animals we can take as the solid matter. Now I think you are get an idea about the solid matters. If we get the solid matters, they have a mass and also occupying space. That's why we take solid matter is one state of matter. Then we will move to the next one. Next state of matter, liquids. So if we get the liquids, look at this picture. In this picture, a lady and a girl taking a glass with a drink. So if we consider about that drink, inside of the glass, it takes the space inside of that glass. And also, they feel how heavy is that. That means the liquid also have a mass and also occupying space. That's why if we get the liquid, we are considering it is also one state of matter. Then we will move to another state of matter. Gas. It is also another state of matter. But I think you are confusing about that one. Because if we consider about gases, we can't see them. Even we can't touch them. That's why you are confusing, is it a matter? Yes, gas also a matter, one physical state of matter. So let's see how it is belongs to a state of matter. There should be a mass and also they should be taken space from the surrounding. Here one example for that one. Here I am taking a balloon without inserting gas into it. And after that, there are several stages in that one after filling gases into it. Okay, in this picture, you can see a balloon in several stages. In the first balloon, there's no air filled into it. But if we consider about the other state, the air is filling in that balloons in different amount. If we get the first one, it takes some space from the surrounding because it is a solid matter. But after that, if we consider about that three state, so the last one take large space from the surrounding. What is the reason for that one? If we get the last balloon, it filled with gas. That's why we can conclude the gases, they also take space from the surrounding. Now let's see gases have a mass. Look at this one. Here also again I am taking another balloon and I am kept that one on a scale. When I am kept that one on a scale, so I get the reading for that one for its mass. It is given in here. But after that, I am going to make a change into it. That means I am going to fill that balloon with air. Look at this one. After filling it with gas, I kept that same balloon on the scale. What happened to the reading? The reading get increases. The same balloon that we used, but the reading in two occasions are not same. In the second reading, it gives a higher value than the first one. How it is increasing? The reason is the air inside of the balloon. That means air also have a mass. Then by using that activity, you can conclude the air have a mass. Then if we consider about all the gases, oxygen, carbon dioxide, hydrogen, helium, like all the gases, they have a mass and also occupying space. So likewise, if we consider about the matters, there are three physical states. So if we consider about that three physical states, one is solid, that means solid matters, then liquids, that is liquid matter, and gas, that is gaseous matter. So I think you are getting an idea about matters and the three physical states of matters well. Now I am going to move to today's lesson. Okay. Before discussing about the changes of matter, I am going to show you some activities relevant to that one. Let's do that activities and get an idea about the changes of matter. Okay, I am going to heat naphthalene. For that one, I am using a metal spoon. First, I am going to heat the metal spoon. After that, I am putting that naphthalene balls onto that metal spoon and cover it with another metal spoon. Let's see what happened in there. First, I am going to light the lamp. After that, I am going to heat the spoon. Okay, now I think it is enough. Now I am getting solid naphthalene and I am going to keep it on the spoon. Now look at that one. What happened? The naphthalene ball start to melting. Then I cover it by using another metal spoon. Let's see what happened in there. Here look at that one. The naphthalene ball is melting. Still it is melting. And if we observe the other spoon, the inner surface of the spoon, so you can observe the white color powder is there. Here, what is that one? It is also solidified naphthalene. Okay, look at this one. Here, the first one we take naphthalene ball and after that we heat it by keeping on a heated metal spoon. After that, we observe the white color powder on that spoon. That means here what happened? The solid naphthalene get into liquid naphthalene. After that, it turn into gaseous naphthalene. Then again it is solidifying. The physical states are changing when melting of the naphthalene and solidifying of that one. Then we will go to another activity relevant to that one. Here I am taken magnesium strip. If we get the magnesium strip, so it do not like that because a magnesium oxide layer is covered by the magnesium strip. That's why when we are doing the experiment, we take the magnesium strip and removing that magnesium oxide layer around it. So after that, we can obtain this like magnesium strip. Then I am going to heat that magnesium strip. So I am taking that one and I use a pair of tongs to handle that, and also I am again using the burner. Just we light that one. observe carefully what happens in there. You can observe the magnesium strip burns with a bright white flame, and there's a white color powder is remaining. Here what happened? Here, when we burn in the magnesium strip, it reacts with oxygen and form its oxide. Look at this one. First we are taking the magnesium strip, after that we heat it, then it burns with a bright white flame and white color powder is remaining. Here sulfuric acid. First I am pouring sulfuric acid into that beaker. Okay, look at the color of it. It is colorless. Then I am using a thermometer to measure the temperature of the sulfuric acid. Here the sulfuric acid. So I am going to measure the temperature of that one using the thermometer. Let's see what is the temperature in sulfuric acid. So first I am keeping that one, and I am going to get the reading of the temperature of that one. Then I take the values that I get as the temperature is 25. So when you are getting the readings, so we need to keep the mercury level with the eye level, and we are getting the reading as the temperature of the sulfuric acid. So after that I am going to make a change in there. That means I am going to put some sodium hydroxide into it. So here I am taking some sodium hydroxide, and I am putting that into that sulfuric acid. And after that I am going to get the reading of the temperature of it by using again the thermometer. Then you can see the temperature rises. In here sodium hydroxide react with sulfuric acid. During that reaction the temperature increases. That's why the reading of the thermometer increases. Now if you see it, the temperature now 33. So likewise, until all the sodium hydroxide dissolve in that sulfuric acid, the temperature increases. That means there's a change occur. So look at this one. So I am going to keep the thermometer out. Look at this one. I am taking sulfuric acid and also sodium hydroxide. First I am taking the reading of the temperature of the sulfuric acid. After that I put the sodium hydroxide into it and measure the temperature. At that time the temperature increases. That means there is a change occur in that two matters. Now I am going to do another activity relevant to the changes. So here there is a test tube. Then I am going to pour sulfuric acid into it. If not, you can use any acid. So after that I am putting a piece of magnesium. If not, you can use piece of zinc, a metal piece and I am going to put that one into that acid. Then observe what happened in there. Now look at that one. What happened in here? Magnesium start to react with the acid. At the same time, the gas bubbles are evolving. That means magnesium react with acid in here. Okay. Here, if we take in the magnesium strip and if we put into hydrochloric acid or any other acid, so at that time the magnesium react with the acid and evolve in a gas. Okay, I think you get something by using that activities that we did. Now I am going to move to the changes in matter. Changes. If we get the changes, we can divide them into two main groups, physical changes and chemical changes. Then I am going to explain about the physical changes and chemical changes separately. First we are going to discuss about the physical changes. So if we consider about the matters we discussed, they are present in three physical states. Sometimes the changes occur in matter by changing only their physical state, by making some changes in their physical properties. So likewise, if we get that changes, we can consider them as the physical changes. Okay, look at the definition. The changes occur in matter where only the physical state change without giving new substances. Simply we can define it as the physical changes. Then if we get some physical changes occur in matters, look at this one, a glass of water. If we consider about the water, it is present in liquid state. And if we pour that liquid into the container and if we keep it on refrigerator, so after that we can take ice cubes out. When what happened in there? The liquid water turn into solid ice. That means liquid turn into solid. Here there is a physical change occur. That's why if we consider about solidifying of liquid, it is one physical change. Then let's see another example for the physical change. Here again, there are some ice cubes. Then if we take ice cubes out from the refrigerator and keep for a while, you can observe the ice cube start to melting. That means here the ice cube present in solid state. After some time, what happened to that one? It turned into liquid state. That means when melting of ice cubes, solid state turn into liquid state. That means change occur in there is the physical change. Then look at another one. In your houses, you are using butter. We are getting that one in solid state. But if you are keeping them on fans and heat it, what happened to that butter? It start to melting. That means the physical state of butter is changing from solid state to liquid state. But the chemical nature do not change in there. That's why melting of butter taken as another physical change. Look at this one. Here some rocks are there. So if we crush that rocks, we can obtain small size rock particles. Here what happened? The physical state not change, but physical properties are changing. That means the size is changing. Here also there's no new substance is formed. The same rock but in different size. That's why crushing of stone we consider as another physical change. So likewise, you can get some other physical changes occur in the environment. Now, I think you can get an idea about the physical changes. Let's see some examples again to get the idea about it. Here, I am getting that one. Melting of wax, condensation of water vapors, crushing stones, vaporization of liquids are some examples for the physical changes. Now I am moving to the next type of change, that is chemical changes. So we know the matters, they undergo some changes by making new substances. So that type of changes we consider as the chemical changes. So let's see what is the definition for the chemical changes. The changes occur in matters where new substances are formed from the existing substances. Now you know what chemical changes mean. Now I am going to show you some chemical changes. Look at that one. Clean iron nails. So if we consider about the iron nails, they are solid matter. Then with the time when they are exposed into the air, what happened to that iron nails? They are get rusted. That means iron react with the oxygen and water vapors which are present in the environment and making the iron rust. It is a new substance. If we need to take iron nails back, we can't do anything to get the iron nails back. That means a new substance is formed when rusting of iron. That's why we can take rusting of iron as a chemical change. Now let's see another example. Now you can see a picture of a firewood. When you burn in the firewood, you can observe a flame and also a black color substance is formed. And also we can't take back the firewood after burning it. That's why burning of firewood is one chemical change. Now let's see another example for chemical changes. Here look at that one. A picture of bunch of banana. With the time, what happened to that one? It is ripening. That means a new substance is formed. Ripening of banana is another example for chemical change. Now you can see a test tube with sulfuric acid. In the next one, you can see zinc granules. So after that, if we are putting zinc granules into that sulfuric acid, what happened in there? So it starts to react. And when it is reacting, you can observe gas bubbles are evolving. The last picture, it shows clearly. So you can see that the gas bubbles evolve at that test tube containing the sulfuric acid. That means a new substance is formed. One is the gas and also zinc is dissolving in there. That's why if we get reaction between the zinc and the sulfuric acid, it is also another example for chemical change. So likewise, if we get the chemical changes, so look at some another example for them. Burning firewood, we discuss about that one. Heating limestone, if we are heating the limestone, at the same manner they give new substances. That's why we can take it as another chemical change. Rusting of iron, burning of magnesium strip. Now I think you have an idea about the chemical changes. The changes occur in matter where new substances are formed from the existing substances. Then, if we get the physical changes, we know the physical state is changing without changing their chemical nature. But if we consider about the chemical changes, we discuss a new substance is formed from the pre-existing substances. That's why there's a difference between physical changes and chemical changes. But if we need to identify the chemical changes occur in the environment, we need to know what are the evidences that can be used to identify the chemical change. So here I am going to discuss about evidences of the chemical changes. The first thing is reaction between zinc and hydrochloric acid. If we take a test tube with sulfuric acid and if we put some zinc granules into it, what happens? In this picture, you can see when we are putting zinc into the hydrochloric acid, what happened in there? So you can see there are some gas bubbles are evolving. That means in the reaction between zinc and hydrochloric acid, a gas bubbles are evolving. So we can take it as one evidence for a chemical change. When there is a chemical change occur, sometimes the gas bubbles can be evolved. Then let's see another evidence by using another activity. So here I am going to explain about the reaction between iron and copper sulfate. So you know the color of the copper sulfate solution. It is light blue in color. So you can observe in this picture what happened when we are putting iron nails into the copper sulfate solution. The color of the copper sulfate solution reduces and there is a powder which is deposited in the water. That means here what happened? Iron react with copper sulfate and you can observe there is a color change occur. So likewise in some chemical changes the color change may occur. That's why changing of color is one evidence for a chemical change. Let's see another evidence by using another activity. Here I am going to explain about the reaction between sodium hydroxide and sulfuric acid. When sodium hydroxide react with the sulfuric acid, what happens is the temperature increases. So in the previous activity that we did, so we get the reading for the temperature before and after putting the sodium hydroxide into the sulfuric acid. What happened in there? The temperature increases. As the same manner, in some chemical changes, what happened is the temperature increases or temperature decreases. Likewise, if we consider about one evidence of a chemical change, we can take the change in of the temperature. Now let's see another activity. So in here, the lead nitrate and potassium iodide is used. When we consider about lead nitrate and also the potassium iodide, both are colorless solutions. And if I pour lead nitrate into potassium iodide, there is a chemical change occur in there. So in this picture, you can see the way that we are pouring that one and the change occur in there. The first picture, it shows the lead nitrate solution and the potassium iodide solution. The second picture, it shows what happened when we are pouring lead nitrate into the potassium iodide. If we consider about the last picture, in here you can observe clearly what happened in there. The color is changing into yellow color, and also after pouring that one, if we keep it for a while, the yellow color solid substance deposited at the bottom. So we consider it as the precipitate. So likewise, if we consider about some chemical changes, the precipitates are formed. That's why we can take it as another evidence for a chemical change. Then look at this one. The picture for the reaction between magnesium and oxygen gas. When we burn in magnesium strip, what happens is it gives a white bright flame and white color powder is remaining. So the first picture shows before heating the magnesium strip. The second picture shows what happened when burning the magnesium strip in air. At that time, magnesium reacts with oxygen and gives a white bright flame. Okay, then it is clear by observing that one, the chemical change occur in between the magnesium and oxygen gives light. So likewise, if we consider about in chemical changes, the light energy, sometimes heat can be evolved. Now I am going to summarize the evidences that we can use to identify the chemical changes. 1. Change in color. Another evidence, change in odor. Evolving of a gas. Formation of a precipitate. Release of heat and light. So if you know these evidences, so you can identify a chemical change occur in the matter. By using that evidences, you can identify the chemical changes, and also if we get the physical changes, by using the changing of the physical state of the matter, we can identify that one. Now I am going to discuss about what are the things happen during a chemical change. It's simply. So if we consider about the chemical changes, the formation of a new substance by combination of two or more substances, it may be happen. If not, during a chemical change, one substance can be turned into two or more substances. So likewise, the chemical changes occur in matter. Now I am going to discuss about the chemical changes in detail. So if we consider about the chemical changes, there are some substances which are participating for the chemical reaction or chemical change. The substances taking part in a chemical changes we consider as the reactants. And after the chemical change, what happened is the new substances are formed. If we consider about the new substances produced by a chemical change, we consider as the product. If we get the chemical change, what happened? The reactants converted into product. So we can represent it like that. The reactants converted into product. So likewise, if we consider about the chemical changes, we can represent it in different ways. Now I am going to discuss about the ways of representing the chemical changes. One way of representing the chemical change is using word equation. That means the reactants and products we are representing by using words. Here, the representation of a chemical reaction using words. Another way of representing the chemical change is chemical equations. That means the reactants and products are representing by using their chemical formulas. Here, the symbolic representation of chemical reaction using chemical formula. Now, you have an idea about representing the chemical changes. Now, I am going to explain you how we are writing the word equation or the chemical equations. For that one, so you need to know something relevant to that one. When writing a chemical reaction, the reactants are written on the left side and the products are written on the right side. And also an arrow is used to indicate the direction of the reaction. Likewise, if we consider about the chemical reaction, the reactants in the left side and the products in the right side, and an arrow used to indicate the direction of the chemical reaction. Let's see some example for the chemical changes. First one, reaction between magnesium and oxygen. Magnesium oxide is formed. Magnesium and oxygen are reactants. Magnesium oxide is product. Now look at the word equation for that one. Magnesium and oxygen are reactants, that's why it is given in the left side. Magnesium oxide is the product, that's why it is given in the right side. So there is an arrow to represent the direction of the chemical reaction. Then we will move to the balanced chemical equation. The symbol of magnesium is Mg and oxygen O2, and for magnesium oxide MgO. When reacting magnesium with oxygen, magnesium oxide is formed and we can represent it by using the chemical equation like this. Now I am going to explain another example. The reaction between carbon dioxide and carbon make carbon monoxide. So if we take the equation for that one, carbon dioxide and carbon are the reactants and carbon monoxide is the product. Then look at this one, carbon dioxide plus carbon monoxide is formed. We use the word to represent that equation. Then I am going to show you the chemical equation for that. Carbon dioxide, the symbol for that one is CO2. For carbon, the symbol is C, and for carbon monoxide, CO. When I am writing the chemical equation for that reaction, I can use CO2 plus carbon C arrow CO, carbon monoxide. Likewise, you can write the chemical equation for that reaction. Now I am going to move another example. Reaction between magnesium and copper sulfate. Magnesium sulfate and copper are formed. If we get the magnesium and copper sulfate, they are the reactants. Magnesium sulfate and copper are the product. Now let's see how to write the word equation and the chemical equation. Then magnesium and copper sulfate are the reactants and magnesium sulfate and copper are the products. So when we are writing the word equation, magnesium and copper sulfate written in the left side and magnesium sulfate and copper, the products, are right in the right side. Then we are using the arrow to represent the direction of the reaction. Now let's see the chemical equation for that reaction. Magnesium Mg, copper sulfate CuSO4 and magnesium sulfate MgSO4 and copper Cu. By using that chemical formulas, we write that chemical equation in this manner. So likewise, you can write the word equation and also the chemical equations by using the symbols and also the words. Now, I think you have an idea about the way of representing the chemical equations by using the word equation and also the chemical equations. Now, I am going to explain about the chemical changes in detail. That means when we are writing the chemical equations, we need to write them as the balanced chemical equation. So, I am going to explain you how to balance in the chemical equation. In here, I am going to show you balancing a chemical equations by using inspection method. As an example, here the reaction between magnesium and oxygen is taken. And when magnesium reacts with oxygen, magnesium oxide is formed. That is the word equation for that chemical reaction. Then here I have taken the chemical equation for the reaction between magnesium and oxygen. The reaction between magnesium and oxygen we can represent like this by using the chemical equation. But it is not balanced. The reason is the law of conservation of mass. In that law, it represents the mass of the reactant should be equal to the mass of the product. Then how we can equalize in that reactants and the product? So we can consider the atoms which are present in the element. So here look at that one. In the reactants, magnesium is there. So here one magnesium atom is used. And look at the other side, the product. In the product, magnesium, one atom is there. That's why the magnesium in the reactants and the products are same. Now look at the oxygen. Here, oxygen molecule. That means two oxygen atoms are participating to make that one. But look at the other side. Only one oxygen atom is there. Now it is not balanced. The reason is in the reactants, two oxygen atoms, and in the product, one oxygen atom. When we are balancing the atoms of a chemical equation, we can't change the chemical formula. The only thing that we can do is we can add the numbers in front of that chemical formulas to balance in the atoms in that elements or the compound. In the reactants, two oxygen are there. By making the change by putting 2 in front of the magnesium oxide, the number of magnesium atoms change into 2 magnesium atoms and number of oxygen atoms change into 2 oxygen atoms. Now, if we consider about the oxygen atom in both sides, they are equal. Here 2 oxygen and here 2 oxygen. Now, let's see about the magnesium again. Here 1 magnesium, here 2 magnesium. That means magnesium are not balanced. Now, I am going to make another change in there. First, I am putting 2 in front of the magnesium. Then, it make into 2 magnesium atoms. And look at the other side. As the product, there are 2 magnesium atoms. Now, if we consider about that equation, here 2 magnesium atoms in the reactants and here 2 magnesium atoms in the product. In reactants, 2 oxygen atoms and in products, 2 oxygen atoms. Now, both reactants and the products are equal. So, that's why we can take 2 magnesium plus oxygen into 2 magnesium oxide is the balanced chemical equation for the reaction between magnesium and oxygen. Now, I am going to explain another reaction and the way of balancing it. The reaction between aluminium and hydrogen chloride. It makes aluminium chloride plus hydrogen gas. Now, I am going to explain how we are balancing that chemical equation. Here, 1 aluminium atom and in the other side also 1 aluminium atom. That means it is balanced. Now, look at the hydrogen. In hydrochloric, 1 hydrogen atom is there. And if we consider about hydrogen gas, 2 hydrogen atoms. That's why we need to balance hydrogen first. To balance hydrogen, I put 2 in front of HCl. Now you can see 2 hydrogen in reactants and 2 hydrogen atoms in the product. That means hydrogen atoms are balanced in both sides. Now I am going to chlorine atoms. Here 2 chlorine atoms and in the product 3 chlorine atoms. Now it is not balanced. How we can balance it? For that one, I am putting 6 in front of the HCl. At that time, there are 6 chlorine atoms and in the other side, we need to make it into 6 chlorine atoms. For that one, I put 2 in front of aluminium chloride. Then, if I multiply 2 from 3, we can get 6 chlorine atoms. That means, in the reactant side, there are 6 chlorine atoms. In the product side, there are 6 chlorine atoms. That means it is balanced. But look at the hydrogen atoms. In the previous one, we discussed there are 2 hydrogen atoms and here 2 hydrogen atoms. But when we make it into 6, what happened? The hydrogen atoms are changed. Here it is 6. To make it 6, so I am putting 3 in front of H2. Now you can see 6 hydrogen atoms as the reactants, 6 hydrogen atoms as the product. That means hydrogen atoms also balance. This is the balanced chemical equation for aluminium and hydrogen chloride. Now look at that one. In the third equation, I mentioned how to balance in hydrogen and chlorine. And the last one, here I need to make the aluminium atoms balance in both sides. Here we make 2 to balance in the chlorine atom. And at that time, the number of aluminium atoms in the products are changing. It makes 2 aluminium atoms. Due to that, I need to make it equal as the reactants. So that's why I put 2 in front of aluminium. Now you can see the balanced chemical equation. Let's check that one. 2 aluminium as product. 6 hydrogen, 6 hydrogen. It is balanced. 6 chlorine and here also 6 chlorine. So likewise, we can balance the chemical equations. Another one. Reaction between sodium and oxygen form sodium oxide. So that is the chemical equation for the reaction between sodium and oxygen. Sodium Na, oxygen O2, sodium oxide Na2O. Then I am going to balance in that one by using the inspection method. Here 1 sodium atom. Here 2 sodium atoms. It is not balanced. That's why I am going to balance sodium atom first. For that one, I put 2 in front of sodium. Then there are 2 sodium atoms as reactants. And in the product also 2 sodium atoms. That means sodium atoms are balanced. Look at the oxygen. Here 2 oxygen atoms and in the product 1 oxygen atom. Now we need to balance that oxygen atom. For that, I am making the change. So what is the change that I did? Here I put 2 in front of the sodium oxide. At that time, the number of oxygen atoms change into 2 oxygen atoms. Here 2 oxygen, here 2 oxygen. Now it is balanced. Let's see about the sodium. Here 2 sodium atoms and here 2 sodium atoms. But when we are balancing the oxygen atoms, we put 2 in front of sodium oxide. That's why the number of sodium atoms in the products change into 4 sodium atoms. So that's why we need to make that change in the last equation. Here I put 4 in front of sodium. That's why the number of sodium atoms in the reactants and the number of sodium atoms in the product get equal. So that's why we can get the balance equation by making that changes. 4 sodium, 1 oxygen and 2 sodium oxide. That is the balanced chemical equation for the reaction between sodium and oxygen. I hope that you are getting some ideas about the balancing of chemical equations. So likewise, you can balance any chemical equation by using the inspection method. So up to now, you are learning about the changes in matter in different ways. The physical changes, chemical changes, and also you learn about the evidences of the chemical changes. Let's see what are the things that we learned today. First, we discuss about the matter. That means the things that have a mass and occupy space. After that, we discuss about the states of matter: solid, liquid and gas. Then we discuss about some example for the physical changes and also the chemical changes. But finally, we discuss about the evidences to identify the chemical change, because mainly we are discussing about the chemical changes. Then we discuss about the way of writing the chemical equations and balancing the chemical equation by using the inspection method. I hope that you enjoyed today's lesson. We will meet on another science lesson in another day. Goodbye.